Starting the recording now. So welcome, and this is a short 20-minute session on how to or creating a business case for advanced process control implementation. It should be about 20 minutes, and then we'll have a few minutes for questions at the end. There will be a recording available as well for this session if you wish to watch it later on or share it with colleagues. That's fine. Okay, so what are the different scenarios that you might run into where you would need to create a business case for advanced process control? So you could be a new adopter for advanced process control and doing a trial project, in which case it's always a good idea to prepare a business case. You could be doing your next APC activity, and in order to get approval for your project, you might want to create a business case and get the approval of management, because there might be several competing projects. Perhaps you're a consultant who needs to convince a client on their first advanced process control project, which is quite frequently the case. Or it could be that your company who has several advanced process control implementations already, and you'd like to basically prepare a corporate strategy on implementing these in a programmatic manner across your assets. So there's different reasons why you would want to prepare a business case. Why do we need a business case? It's fairly obvious, but just a few points here. Really, the whole process of preparing a business case, besides the fact that you get some kind of financial information about your plant and your return on investment, etc., it's also a good learning process for understanding the plant that you are preparing a business case for, the constraints that you have, and really viewing the process data and doing some statistical analysis, understanding how the plant behaves, perhaps seasonally, and the different conditions, winter, summer conditions, day-night conditions. And also you will learn something by interviewing the operators. They might say, the plant is limited by amps on a pump, but those amps are not visible on the DCS. So there's sometimes there are hidden constraints, and by having these conversations, perhaps a lot more is revealed than just what the data shows you. So enhanced understanding of the process and constraints is a big part. And obviously, if you are looking to embark on a journey of APC projects, then really you can use the business case to prepare a return on investment type of calculation, which can be presented to your management, and they will then decide whether or not the project is worthy of taking forward. Also, while you're building the business case, you create a lot of awareness from different stakeholders within your organization, and you also help build consensus around the technology, the benefits of the technology. There's lots of conversations that take place, and all those things are very helpful, because quite often, as we all know, the technology might be convincing, but it's quite often difficult to convince people. And by going through this process, you generate a lot of those discussions, and which are very helpful earlier on. And if you can convince people earlier on, that means that you have less of a battle while you're doing the implementation itself. So what resources do I need to build a business case? You need access to process data and lab data. Typically, this is 1 year of data. Process data could be 6-minute averages or 10-minute averages, and lab data, typically you have samples taken once a day or once every other day, for example. And really what you need is a set of process schematics. You need DCS screen prints or a overview of the plant or PFDs. Quite often I like drawing my own little schematic summary on a single sheet of paper, which is easy to refer to, and then you can sort of get a very good feeling for how the process is. You also want to look at key quality measures, constraints, and targets, and we're talking about, you know, the key parameters. We don't need to look at you know, 10, 15 parameters. We really want to pick 2 to 4 parameters that are the main strategic parameters for that particular operating facility. You need to have some good discussions with process and operations staff to understand what these key constraints and targets are, really to validate the process data and the understanding that you have from the data itself. And the overall optimization objectives, this is very useful to formulate a profitable strategy for that part of the plant. Quite often you can have this discussion with people who are in the planning department, and if you don't have that type of organization, those types of people, then it would be some senior operations people who would give you the overall objectives for the asset, and it's good to understand those as well as part of your building of the business case. So in terms of methodology, basically we start off with identifying some key parameters, and these could be examples are product flows, qualities, feed rates, fuel, you know, utilities such as fuel, gas, steam, oil, electricity. You also want to look at product qualities in the sense of impurities in that are allowed in a more valuable product, and I'll touch on that a little bit more. So really the idea is to identify about 2 to 4 of these parameters and extract and review data for about 1 year for those parameters. And by review, I mean doing some statistical analysis on that data. So you inspect the data, and then you can calculate the benefits, and I have an example to show you sort of the typical types of things that can be done. But really the idea, the main benefits coming from APC are really coming from a reduced variation in key parameters such as qualities. You can increase, for example, feed rates if you can push against some constraints, and those constraints could be sort of hydraulic limits, it could be safety limits, etc. Or it could be the loss of a more valuable product in a less valuable stream, for example. And then once you have all of that information, you can calculate the benefits, and then you can also calculate the costs for an advanced process control implementation and come up with a return on investment. So a fairly data-driven type of approach. This slide here shows typically or one way in which advanced process control can generate benefits. So let's imagine that this trend here is showing the amount of ethane that is being slipped into a propane stream. And let's assume the propane is more valuable than the ethane, and the maximum amount of ethane that is allowed in the propane stream is 3%. Without advanced process control, and this is an exaggeration, obviously, there is some level of variation in that impurity going in the propane stream. And the result of that is that the operators will operate at an average which is a little bit further away from the actual target or the actual quality measure that is set perhaps by the where it's sold, so to speak, and that perhaps is at 2%. And you can also see that depicted here, where you have a distribution which is very flat because of the nature of the way this is varying, and the average is 2%. With advanced process control, you can squeeze that distribution, meaning you can have less variation, and which means you can shift that average a little bit closer to the actual target of 3%. So let's say it shifts by 0.7%, and that extra 0.7% is really perhaps generating extra flow, which means that you are effectively selling ethane as propane, right? I mean, that's basically what it comes down to. But obviously within the specified parameters that have been set by the quality, which means that you're still within 3% maximum. So this is a fairly typical way how APC sort of can help you generate benefits, and the calculations are based sort of on this principle. So in terms of methodology, how do we understand, how do we get to these values, and how do we actually calculate these numbers? There's a rigorous way of doing this where you would build an initial advanced process control model and simulate that model to calculate the benefits. This is a rigorous method. It is very accurate. It's time consuming, and typically you would perhaps, if you have the skills in-house at your facility, you could do it yourself. If you don't have the skills or the software, you might need to ask a consultant to do this for you, and it may not be free. There's a second method which most people tend to use, which is you assume some benefits, and these numbers are really coming from sort of industry trends and industry experiences, and you can reduce the standard deviation or improve the variation in certain products by about 30 to 50%. You can reduce energy consumption by 3 to 8%, increase feed rates by about 2% or more, constraint dependent. So, you know, these numbers are, I'm sort of putting them out there, but obviously you would need to look at your particular industry and your particular process to really to apply these numbers. You would also use, for example, I use 330 days of year, 330 days per year of plant being in operation, and also the fact that 70% of the time that the process is pushing against the constraints. And I'll show you how we use these numbers in examples coming up. And in terms of cost, on the cost sides of things, you want to look at one-time costs such as software and services, computers and infrastructure. And also, you mustn't forget annual costs, which could be software maintenance costs, services. I mean, people quite often forget about maintenance services. Everybody's very hung up on maintaining software and hardware and doing training, but you know, you need to budget for having either your own service, your own staff assigned to the maintenance of these applications, or taking on help from a consultant who can help you, you know, once a quarter or something, to make sure that these applications are operating at the best possible and generating the most benefits for you. So let's take an example. This is a refinery example, or an example from facilities which use hydrogen. So if you have a hydrogen network, you have a hydrogen producer and several consumers. And the objective here is for the hydrogen producer to increase or decrease production to meet the demand of the consumers. And this obviously happens by the operators on the hydrogen production side adjusting the production based on what the pressure is in this hydrogen network. If suddenly this hydrogen consumer reduces their consumption, you will have a pressure buildup, and you know, you will have that hydrogen going off into the fuel gas header and being burnt as fuel gas. Obviously, good operators will see that coming. They will make the adjustments fairly quickly, and you will perhaps avert this scenario. But quite often, these disturbances happen quite quickly, and you might end up with some losses here. Now, with advanced process control, we know that this particular type of situation is kind of very well suited for APC, because you would operate this hydrogen plant APC at a very high frequency of, let's say, 20 seconds, every 20 seconds, which means that the hydrogen network pressure is being monitored very frequently, and you can have the possibility of acting quickly and reducing these losses of hydrogen to fuel gas. And the net result is that your average hydrogen loss, perhaps, I would say, can be reduced by about 20 to 30%. And you can quite easily do that calculation by either looking at if you have flow measurements on the hydrogen or some way of calculating the flow. You can either use that and maybe look at 1 year of data and then say, okay, it's on average it's so much per year, and reduce it by 20-30%, or you can use the other side, which is on the production side. You can look at fuel gas and feed and look at if you can what is the reduction in fuel gas usage in the reformer, or the reduction in feed to the reformer. And the feed, as we know, is natural gas, so there's benefits there as well. So you can either do the calculation from the reformer side or from the hydrogen side, but those benefits will be quite big. My second example is a distillation column example, and this image has been taken from sciencedirect.com. It's showing you a set of 3 distillation columns: a deethanizer, depropanizer, and a debutanizer. The objective here is to separate into the 4 different products. So we have ethane, propane, butane, and pentane. And let's assume the product values are propane is the most valuable, followed by butane, pentane, and ethane is the least valuable, right? And in this situation, the strategy here would be to minimize the loss of propane in the ethane. So we don't want any of the propane, or minimize the amount of propane going here. We want to maximize the amount of ethane going here, because you saw in the previous few slides where we want to maximize this impurity to whatever is the allowable limit here, because then we are selling ethane as propane. And the same on the debutanizer side, where we want to maximize the pentane in the butane and minimize the butane in the pentane. So this is a typical type of strategy. And I use these terms maximize and minimize, not in the sense of, minimize to 0 or maximize to 100, but more in the sense of maximize or minimize towards the allowable limits. So in this particular situation, what we can do is, if we look at the propane stream as an example, which I mentioned earlier, if we were to increase the amount of ethane impurity by 0.7%, and again, you can calculate this by looking at historical data for the amount of ethane impurity in this stream. You might have lab values, or you might even have an analyzer. And you can look at the average and standard deviations, and you can assume, a reduction of 30-40% in standard deviation, and calculate what this delta would be. And then relate that 0.7% to an increased flow of propane. And there's many ways of doing this, but you can also look at sort of a molecular basis, convert the amount of extra percentage of ethane into a flow, and then look at the differential in the price of propane and ethane, and multiply it by the number of days a year, hours, and this is the 70% of the time, which is the factor that I use, but you might choose to use a different factor, and you will end up with a dollars per year type of benefit here. And that's really the objective, is to calculate this this number. And in the end, you will end up with for this particular flow sheet, so to speak, you will have benefits that are increased recovery of propane and butane, and you will also have energy reduction in some shape or form, and you could measure that as energy consumed per unit of feed or per unit of product produced. And that could be a total energy. You could either do it for each unit, or you could do it as a cumulative thing. Sometimes these reboilers are using energy from, waste energy from other processes, in which case perhaps you don't want to bother doing that calculation. But if they are directly using steam, then it's perhaps sometimes worthwhile doing that calculation. But from experience, energy is not necessarily a huge amount of is not a big contributor towards the overall benefits. Okay, so then we want to prepare and present, and what you want to do is to annualize the benefits, and then you want to calculate one-time costs and annual costs, which I showed earlier on, and show a return on investment. And while you're going through this process, it's always good to get some of your peers to look at these calculations and numbers as you go along, so that you sort of get validated that the path you're on is correct and it makes sense. And always good, like I mentioned earlier, to collaborate with stakeholders and seek their consensus. Very good idea in your presentation or in your report to show the risks and opportunities of the technology or implementation of the technology. And it's some of the risks, I would say, which are not necessarily risks, but more like challenges, are training. Training your staff in the new technology. Maintenance is also a big challenge. Like all technologies, you have to have dedicated people looking after these applications. Otherwise, they stop being useful and stop generating good benefits. So those, I would say, are risks, and also in terms of opportunities, you want to make sure people understand that these technologies reduce, for example, alarms. They will reduce operator stress. They will also produce a plant that is more consistent in its operation and not dependent on operator knowledge. So all these are opportunities that you must show in your presentation. So my last slide. So in summary, I would say understanding the process is key to generating a business case. It's very important not just to look at the data, but also talk to people. And then choose the variables that are easily understood. So, don't try to overcomplicate things. Choose sort of maximum of a handful of variables, typically 2 to 4. And then it's important to build consensus amongst all the stakeholders, so that when you are doing your final presentation, everybody is sort of in agreement and you don't have big challenges in sort of selling the idea or selling the business case. And when you present the business case, make sure you look at long-term benefits and risks and opportunities as well. So that's all I have. I thank you for listening, and I will open it up for questions if there are any.